Okay, so what we got here right now is a Nissan. It's an MCP. Just a CP. Is that MC? Oh yeah, it's an MCP 1F2825LV. And the complaint from the customer is it's running rough. It's like a misfire. So let's try to crank it. Start it and see. Alright, let's confirm. It is really running rough. Feels like a single cylinder mess. Okay, so in order for me to determine if this is gonna be a mechanical problem or the engine has low compression or whatever mechanical wise to produce that misfire, we're gonna do a cranking sound test. So what I did was I let the engine run out of fuel, kill the tank, and so we're gonna listen for the sound that it makes when it's cranking. And what I'm looking for is an even cranking sound, and that would tell me that at least my cylinders are almost equal in compression. I'm not saying it's going to be good compression, but because I'm only after probably a single cylinder miss, if it is mechanical in nature, then I would hear an uneven cranking sound. Okay, let's try to do that. Okay, cranking. Oh, try to start. Running the gas. Do that again. So I didn't hear any definitive unevenness in that cranking. So I'm gonna go away from checking the mechanical on this one, unlike the TCM that I worked on before. And we are gonna try to do a power balance test next. Okay, so before I go to the power balance test, so I want to see, because I have my check engine light, do I have a code present? Let's start it up. Okay, so check engine light went away, so it means to say there's no code that is presently active on this truck. Okay, so we are going to proceed with the power balance test next. Okay, in order to figure out which of these cylinders is misfiring or is not contributing, we're going to do a power balance test, and the way we're going to do that is to pull each of the connectors one at a time and see which cylinder has the least RPM drop. Okay, so I'm gonna start with the number 4. Okay, that's a big drop. It's not number 4. Let's try number 3. Okay, that's a big RPM drop. Number 2. Okay, that has an RPM drop. Yeah. Okay, let's try number 1. So it's more likely to be number 1 because we all went through all the cylinders now. And nothing. So now we know it's number 1. Okay, so I took out my Pico. Right now I'm on setting for 5 seconds per division because I'm just going to be testing battery voltage and the negative for that coil first. So I have my negative hooked up to the battery. Test out if put my blue lead there on the battery. Just make sure that we are getting a good reading or a good connection. So okay, so we're good there. So bring it over to here. I want to test out the power supply for this coil. So I know that the green is going to be the power, and the black would be the negative, and the brown would be the signal. All right, so let me test out here. I'm connected up to the negative, and so let me back probe in this guy. All right, key on. Let's see if I get a reading. Okay, so positive is there. All right, 12 point something. All right, so we're good on the positive. What I'm gonna do next is I'm gonna put this on my positive. So there, I got a good reading. That's 12 volts. And then I'm gonna test out for the negative on the other one. You know what? Let me try to do this. Let me change this up. Okay, just gonna do the positive on this one. This one should be the positive. Okay, hook it up to the positive, and then I'm gonna do this is where we're going to be using to probe on the black wire. So I got my positive on the blue trace, gonna check for a negative. So we're back probing on the black wire. All right, and there you go. I see the 12 volts again. So that would tell me that the positive and the negative supply for that coil is good. So now down to the signal coming from the computer. So I got my negative back, or the black lead back on the negative. And now, just for reference, we're gonna test out number four coil, because we know this is working good. I'm hooked up, back probing the signal wire for that number 4 coil. All right, settings is gonna be 200 milliseconds, but we can adjust it later anyway. All right, let me crank this up. But first, okay, cranking should produce a signal, so let's see. Okay, let's see that. So I know at least I produced a signal on that one. Let me go back. There's my signal there. Let's zoom in on that one. Okay, kill this. So that is what the signal should look like. The maximum we hit was 3.628. Alright, but we know that's a good signal because number 4 is a working coil. So now I'm going to transfer my leads to the number 1 and see what we get. Okay, so lead now is transferred to the number 1. I'm going to run this now. This out. Okay. Run it. Okay, let's crank it up again. Let's see if we get the signal out of here. I do, but I don't like what I'm seeing. Let's go back. I did see, there it is. Let's zoom in on this guy. It's way below than it was for the number 4. Right, so that was number 4 earlier, and this guy was only hitting almost nothing, half a volt. All right, so that's the reason why we don't have spark on that number 4, I guess, or not. It's not contributing. Without a good base signal for the transistor inside that coil, it's not going to produce a spark. All right, so now I got 2 issues now, possible issues. One would be, I hope that it is, that we have a high resistance in the wire, which this design is bad for, corrosion and stuff like that, brittle wires and whatever. But the next thing I'm going to do is, now I'm going to have to test it on the computer side. So same principle applies. If I see the right signal from the computer side, then I know it's going to be a wiring issue. It's down to tracing the wire and where we have that high resistance. But if it is the same on the computer, then more likely it is the driver inside the computer that is faulting out for this one. So we're gonna try out on the computer next. So I got the computer out of the sidewall, took out the cover from the top. So now we're back probing into pin number 62, which is the base signal for the coil for number 1. Right, so I'm gonna put the battery back, and we're gonna look at the waveform again and see if it's gonna be a right signal coming out of this computer or if it's the same. Channel 1 on the computer, battery's back, got my negative there. Okay, I got my oscilloscope running again, and let's try to run this one. Let's see. All right. And okay, try to turn this off. I've seen what I needed to see. All right, so this line here is where it should have been. All right, that's 3.6 something, and you see the signal. Even though from the computer side we're back probing on the pin and still the same signal, so almost non-existent. So right now I think that's gonna be a computer. Alright, I don't think it's gonna be a power ground issue, because the other coils have 12 volts, and even this coil, right? So it's just the signal. Okay, so it's gonna be a computer for this one. All right, I know they have multiple trucks of this type in here. Let me check if I can borrow one of those computers and plug it into this truck, and then we can verify if it is actually the computer. Okay, so nice enough. They were nice enough to let me borrow the computer from the other truck. So this is the original computer on the truck that I'm working on. This is the computer from the other truck. So we're gonna try to plug this one in and try to verify the problem, or what I've said earlier, that this is now gonna be a computer, the driver inside the computer. So I'm just gonna plug it in, and then we're gonna see and look at the waveform again for ignition coil number 1. So swap the computer down there. That's the old one. So we're back probing again on the number 1. Negative on the battery. So let's try to crank it. Focus on the screen. Okay. Aha! There it is. And even the sound of the engine now. Don't hear the cylinder misfire anymore. Let's rev it up. Okay. Sounds what it should be. Alright. Let's look at the signal now. Okay, pause this. Okay, go back. There it is. Let's zoom in. There it is. That is what the signal should be like. Alright, so it is a computer. Unfortunately for this customer, so we're gonna have to buy a new computer for this. So the only thing I have to do right now is, of course, take back the computer that's in this truck right now, put it back on the original truck where it was, and now it's up to the customer if he wants a new computer on this. But for this truck, I would call this one not a fix, because we need a computer, but it's properly diagnosed now, so it's just a matter of changing the computer if the customer decides to, and this will be fixed.